All right, so we were here. I want to do this problem. I want to practice some more. All right, you're director of alumni. You want to determine if there's a linear relationship between the number of years out of school versus your contributions. All right, this is in thousands of dollars, so be careful. The data is shown at the left. Display the data in a scatter plot. Hang on one. Oh, God. Okay. Right. Okay. No worries. All right. I was thinking something. All right. So I'm going to go to list one and type that information here. List one. I'm going to type this in list two. 1. And all right. So I typed it in list one. I'm just going to go ahead and I'm going to push window. All right, and I can see it. It's pretty much down. So we think it's negative. I'm going to go to stat, calculate. Number 4. I'm going to make sure this is in list 1 and list 2. All right, and I get this data. So let me write it down. What the calculator says. I'm going to round. Negative 0.38 equals 12 point. All right, so, oh, yeah, I need to go 2 spots because this is to the 10th. 12.88. And I get R is negative 0.91. All right, there are 1, 2, 3, 7. So that means my degrees of freedom is 5. And let's do, I don't know, alpha is 0.01. Okay, and so I'll tell you that alpha in the problem I didn't sample. 0.015. Let's go up. Find that table. Oh, another 5, so that's fabulous. And 0.01, great. 875, 875, 875, 875. All right, we got for table I, we got 0.875. All right, and so we need to compare P and absolute value of R. So P is this guy, 0.875. We need the absolute value of negative 0.91, so that's 0.1. That guy's bigger. Remember, our null is P equals 0. Alternative is P does not equal 0. This guy means there's no relation. This guy means there is a relation. All right, and so when it's less than, we reject the null. So we're going to accept the fact that there is a relationship. All right. Determine the type of correlation. So there is definitely a negative correlation. We're going to accept, or there's enough evidence to accept that there's a negative correlation. So then I could ask you questions, or actually, then I would say, hey, what is the equation? And so we would write negative 0.38x plus 12.88 would be the linear regression line, the line of best fit. And then we could say, okay, let's say somebody has been gone for 2 years. How much do you think that they would contribute? And so we could do negative 0.38 times 2 plus 12.88. And I get negative times 2 plus 12.88. I get 12.12. And that's thousands of dollars. So $12,000, $12,120. So that's all together. All right, so before, or up until now, we've been using table I to calculate some values. Let's do an additional example, and let's do the p-value using the calculator. I should have changed that, sorry. All right, so this is the breathing rate of goldfish versus like their temperature. So first, let's see if there's a relationship. So I'm going to go to stat, edit, 9, 12, 15, 18, 21, 24. Oh my gosh, it didn't stay in the same column. Let's try this again. 9, 12, 15, 18, 21, 24, 27. And then list 2, 48.5, 46, 59.8, 58, 86, 86.5, 110, 124. All right, and this is where I got the data. I just don't want to you think I'm making this up. All right, so I put those in list 1 and list 2. I'm going to go to stat, calculate number 4. All right, and so when I do that, I get R equals 0.97, which means most likely there's a positive correlation. There's one little outlier, this 12, but otherwise the more you do it, the higher it becomes. All right, notice we went to stat edit and then we went to linear regression to get this R value. I want to show you something else. Yeah, I want to use this linear regression t-test. All right, and even though it's called t-test, I'm looking at the p-value. To get there, okay, and notice everything that we're going to do is going to match as if we had just done the regular linear regression, except it gives us a few more information, okay? So this is pretty good thing. So we're going to go to stat, because we're in statistics. Stat, then we're going to go to calculate, and then we're going to, or test, I'm not, this is test. Test. Then we're going to go to F. F says linear regression t-test. All right, and here's the great thing about this. It's going to tell us a whole bunch of stuff. It'll tell us the p-value, so we don't have to look it up. It'll tell us the degrees of freedom. It'll tell us the A, B, R, all of that. It's going to tell us all of it. Okay, this is the rest of it. And notice everything exactly matches. So do that. Okay. Make sure that it has the right thing, like my stuff is in like 2. Make sure it says not equal to, and then you calculate, and it's going to tell us all this stuff. And so it's right here. I took pictures. Well, I got it from the website. We get the same exact data. Okay, this S is the sample standard deviation, just so you know. It tells us all this information. Okay, and so if we wanted to, we could, because it tells us the p-value, we can compare P and alpha versus having to compare P and R. Well, what we would get for R. And so P is this 2.06 and it's -4, so we would go 1, 2, 3, 4. So that is really 0.0002 is our p-value. And so our alpha was 0.05, our p is 0.0002, and he's less than. And so we would reject the fact that there is no correlation. We reject the null. All right. Another way you can verify it is that we could. There's 1, 2, 4, 5, 6, 7 things. And so we can go look up N5, 5. So, yeah, find that. I hear my dog. It's like, I'm tired of learning math. I'm sure you are too. N5 of 5. So 754. 7. right, so we would get P equals 0.754. We would compare it to that R, so it would be 754 and 0.974. Uh-oh, hang on, guys. All right, sorry, my dog got sick. Okay, so even if we use still table I, that's where we got this value, is table I, and we compare it to our R value, we're still going to get rejection because less than is reject. And so there is enough evidence to accept correlation. I have horrible handwriting on this computer. All right, and so we can use this data and we can write the linear equation regression model. All right, notice if we just did the regular, we would get the exact same data as if we did this linear regression t-test, okay? And so that equation is going to be y equals, this goes to tenths, so we need to go to hundredths, 4x minus 1.57. All right, and so, oh, it said hundredths, that was next to it. All right, and so the temperature is x, and so we would do y equals 4.54 times 19.5 plus negative 1.57 to figure out what the breathing rate is. And so 4.54, 19.5 plus negative 1.57. I get 86.96. Right, 19.5 is in between these two numbers. So it's a little off, but it still makes sense. It's still within that range. And so let's do another one. Because we verified that there's a relationship. So since there's a relationship, we can make predictions. All right, so if the breathing rate is 128.55, what's the temperature? 4.54 x minus 1.57. I'm going to add 1.57 both sides. And so I get 120.55. 130.12 equals 4.54x. I'm going to divide by this 4.54. That's an x. 4.54. So I'm going to divide by 4.54. And I get x is 28.66. Sure. The temperature would be 28.66. All right, let's look and see if this makes sense. So 128 is here. And so it's after 27. It's pretty close. And so that makes sense that our number would be close to 27, but greater than. All right, so you did it. You've watched all the videos for stats. All right, go do some practice work so you can reinforce the ideas, and I will talk to y'all later. Bye.